Hello, I'm Emma Louise Coffey, and you're welcome to the Dairy Edge, the Teagasc Dairy podcast. We're bringing you the latest information, insights and opinion to improve dairy farm performance. Here at the Moorepark Open Day, we speak to John Upton, Prendergast and Fergal Buckley, who compare labour and energy efficiencies that exist on farms milking with herringbone and rotary parlours. And first, I asked John about the importance of achieving an efficient milking process.
I think it's a KPI that a lot of farmers potentially aren't looking at. And by milking efficiency here, I suppose we mean how many cows are being milked per hour, which directly affects how long you spend in the milking pit. We know from some previous work that we have done that some farmers are milking well in excess of 7 hours per day. So we decided to start this project, I suppose, to get a bit more detail in terms of what's going on under the hood during the milking process. And then, why should we compare herringbones and rotaries? Well, rotaries, I guess, are seen as a solution to labour shortages on farms, especially on larger farms. So we thought it would be a great idea for farmers to see a little bit more about how the rotary performs in terms of milking efficiency relative to the herringbone parlours.
And as you say, the rotary parlour is seen as a solution. To look at them, how popular are rotary parlours at the moment, John?
Well, definitely we're seeing a lot more of them going in the country over the last 2 or 3 years. And I think they're becoming almost standard fitment now on farms over 300 cows. But as we'll discuss later on, we're seeing them being implemented on farms even at 100 or 275 cows. So I think their popularity is certainly increasing, and we're definitely seeing them going in on farms now of all sizes, over 200 cows.
And to you, Ryan, you engaged in this study with farmers. Can you give us some insight into what the study entailed and what you measured?
Yeah, so data collection for the study was carried out over 2 phases. So we've late lactation recordings in 2020 and early lactation recordings in 2021. The late lactation recordings have been analysed and they form the basis of this open day paper that we're presenting. We have collected early to mid lactation data this year as well, and we're currently in the process of analysing it. The study consists of 2 groups, one for herringbone farms and one for rotary farms. Many of them were based in the Munster region, however, there's a few Leinster and Connacht farms in there as well. Our herringbone farms consist of 17 farmers. Their average herd size in 2020 was 174 cows, average system size was 18 units, and the average number of rows was 10, and the average number of operators at milking was 1.5. For the rotary group, which consists of 10 farmers, their average herd size was 386 cows, their average system size was 50 units, their average number of rotations was 10, and the average number of operators at milking was 1.
To get a little bit more into those figures, so you're seeing 174 cows in the herringbone average farm, and up to 386 cows for the rotary. So you're looking at a larger herd size on average with your rotary parlours. You mentioned your 10 rows in the herringbone and 10 rotations in the rotary. But what sort of a range did you see there in relation to rows?
So there was a lot more range in values in rows with herringbones than we've seen with rotaries. So for the herringbones, we've seen an average of 10 rows, but the minimum number of rows documented was 6, but the largest number of rows was 19, so which would give rise to larger milking times, therefore might be lower milking efficiency as well. Whereas with the rotary farmers, there was less variation. There was an average of 10 rows we've seen, but we only documented a minimum of 7 rotations and a maximum of 12 rotations. So there was a lot less variance in the values for rows in comparison to the values for there was a lot less variation in the values for rotations as opposed to the values for rows with herringbones.
Back to John's point in terms of cows milked per hour, can you give us an indication in terms of what the both systems were able to achieve on a per hour basis?
So what we documented from the herringbones in late lactation was that they were averaging 105 cows per hour, with ranges from 52 cows per hour up as far as 200 cows per hour for the herringbone groups. For the rotary groups, we documented an average milking efficiency of 155 cows per hour, with ranges from 78 cows per hour up to 189 cows per hour.
And a huge range there, I suppose, particularly when you look at the herringbone parlour. Talk us through automation that you would have seen within those, let's say, look at the herringbone first. Was there more or less automation within those herringbone parlours?
So there was kind of a lot of levels of automation documented on either the herringbone or the rotary groups, both inside and outside the parlour. So the most common one we seen was the ACRs, which was present on 82% of the herringbones, in comparison to 100% of the rotary farms. All of them had ACRs installed. Cluster flush then was only present on 17% of herringbones, and no rotary farms had cluster flush installed. 77% of the herringbones had a teat spray hose system installed in the parlour, whereas 70% of the rotaries had automatic teat spray system installed within the rotary system itself. 35% of the herringbones had automatic feed dispensers in the parlour, compared to 100% of the rotary parlours. 17% of the herringbones had automatic backing gates then in the holding yard, compared to 70% of rotaries having them installed. And only 70% of herringbones had automatic entry and exit gates installed in the parlour. So there was kind of a wide range of automation documented in either herringbone or rotary groups.
And did you see that the farmers that achieved the higher level of output per hour, are those the farms with the higher level of automation in the parlour?
It's probably too early in the project for us to be saying that, but that's exactly what we're trying to find out in the project. And the next step on the road is to combine the early lactation recordings with the late lactation recording milking efficiency data, then merge these results with our infrastructure survey results, and then carry out our statistical analysis. This will allow us to quantify the effects that different levels of automation, as well as alternative management strategies, can have on the milking process and thereby milking efficiency. From this, we're hoping to provide farmers with sound rationale when they decide to invest in their milking facilities.
And I guess a final question for you, Ryan, in relation to, I think we're fairly clear on a lot of the practices that you've talked about in terms of ACRs, cluster flush, your teat spray. But in relation to the automation of exit and entry to the parlour, can you just clarify what exactly you define that as within a parlour?
So in our study, we would have defined the automatic entry and exit gates as like the farmer could operate that system from anywhere within the pit.
Yes.
That they could, if they were at the top of the pit, they could open the exit gates without having distance as a factor in that. They were able to control that from anywhere within the pit.
And to you, John, like Ryan has given us insight into, a wide variety of measurement and huge range in terms of the number of rows and the output achieved in terms of cows milked per hour. If you could reflect on what Ryan has presented to us, what do you see as some of the key efficiencies to achieve that throughput or from a labour perspective on farms?
Yeah, there's definitely a lot of range among the milking efficiency performance within that group. And, we do have some insight from previous work that I carried out in a smaller study in 2016. And the conclusion that we came to from that study were that good cow flow through the parlour was really vital in terms of free flow through the entrance and exit gates to ensure an easy transition for the cows in and out of the parlour. That really does have a large effect in terms of driving milking efficiency. Second, then, I suppose an adequate number of milking units for the herd being milked is crucial in order to have no more than 8 rows of cows ideally. And then when that's coupled with appropriate levels of automation in terms of ACRs and so on, you create a very potent mix then to improve your milking efficiency. And finally, and it's often omitted, but high levels of management and organization within the farm gate does contribute to improved milking efficiency also. What I mean by that, I suppose, is well-defined SOPs for pre and post milking routines, for example, having everything to hand in the pit when it's required so that the operator can remain in the pit during milking is also very, very important to achieve high levels of milking efficiency.
There's some excellent points, John. If we could turn our attention to you, Fergal, and in combination with the study carried out on these farms, the 27 farms that Ryan has mentioned, you have focused on energy efficiency. What metrics did you measure?
So the main metrics used to compare the farms were kilowatt hours per cow, kilowatt hours per 1,000 litres of milk, and cost per cow milked. The night rate energy consumption was also determined to investigate the potential impact that taking advantage of cheaper night rate electricity could have on energy costs of milking.
You know, we would have spoken previously, say with you, John, but I mean, Fergal, from your results from this study, could you give us insight into the main energy sources that farmers would have used, I suppose, to fuel the farm, and also then the areas of energy consumption, I suppose, the greatest draws on energy?
So most of the equipment used for milking is run on electricity. In this study, we had 3 farms that used solar PV to generate electricity, to reduce electricity demand during daytime hours. Water heating was the only energy consuming activity which didn't always use electricity as its energy source. There was 18% of the farmers, the herringbone farmers, used gas to heat water, while 50% of the rotary farms used either gas or oil to heat their water. And for the energy consumers then, the main energy consumers were the milk cooling, the water heating, and the milking machine. On average, milk cooling was the highest energy consumer for the herringbone farms, while water heating was the highest consumer for the rotary farms in the study.
And John, one of the metrics that Fergal has quoted is the cost per litre of milk produced. You've quoted that in the past. Could you give us an idea, what is the average cost for energy per 1,000 litres of milk produced?
So the average figure from my research work to date is €5 per 1,000 litres of milk produced, which works out at about €5,000 per year for every 100 cows that are milked. And the range around that figure then would be from €2.50 at the lower end up to €9 per 100 litres on the higher end.
And Fergal, how do those kind of national average figures that John is aware of from his work, how does that compare to the 27 farms that you looked at?
The energy costs for the herringbone farms that were included in our study, the average was €6.69 per 1,000 litre, with a range between €4.13 per 1,000 litre and €9.14 per 1,000 litre. For the rotary farms, it was €7 per 1,000 litre average, with a range between €3 and €11. These are slightly higher than the national average figures, but that will be because these figures are calculated based on late lactation period. It would be expected that these figures will reduce very slightly and should come very close to the national average figures when the full lactation period is taken into account.
That's a really interesting point, Fergal. The figures that you're looking at from the perspective of the rotary, slightly higher than that of the herringbone. Is that what you would expect? And what would you owe those costs to?
They're very similar, but there is a slight difference in this part of the study between the herringbones and the rotaries. I think it might be a little bit too early to say until we compare the entire year's worth of data to say which one is consuming more consistently or which one is more expensive to run. At the same time, the rotary parlours are typically much bigger and they would have much larger equipment involved. They also have additional technologies in use and they may also have higher levels of automation. All of these things may cause extra energy demand compared to the herringbone farms. So that's part of the reason why it's so important to look at the relationship between milking efficiency and energy efficiency to see if increasing your energy efficiency or your milking efficiency may have an impact on the other side.
And to you, John, again, to reflect on what Fergal has said and the results that he is seeing in late lactation in terms of energy costs. Again, some practices that you see as the greatest wins for farms from an energy efficiency perspective.
I suppose the first thing to note really is that if you're not measuring something, it's hard to control the cost. So I'd encourage every farmer to compute their energy cost per litre of milk, which is a very relatively simple calculation. You would just simply divide your quantity of milk sold over a 12-month period by the electricity costs over that same period. And then you will get a great feel for whether you're high, medium or low. And based on that, then you can take appropriate action. So If I was to divide it up into measures then that could be followed after that calculation had been done, you could draw a line between, we'll say, cost reduction strategies and energy reduction strategies. In terms of just reducing costs on its own, very simple to do. Sign up to the cheapest supplier every 12 months. That involves a big saving usually. And also use as much night rate electricity as possible. So those two things are very powerful in terms of reducing costs with zero spend. So a very attractive option. In terms of reducing energy consumption then itself, you're looking into getting into the energy efficient technologies. And if I was to rank those, we'd say in order of importance, I would put the plate cooler first to chill the milk before it goes into the tank. Following on from that, I would look at investing in some solar panels to generate some renewable electricity from the sun, which will in turn cut down on the farm energy bill. After that, I would look into getting a heat recovery system in place, which will capture waste heat from the milk cooling process in order to preheat your water for your water system. So again, a very useful technology, especially in these days where there's a much higher demand for hot water on farms than there used to be. And finally then, last but not least, the variable speed drive vacuum pumps are a very effective way to reduce the energy consumption of the milking machine. So they're the four kind of whistle-stop tour of the technologies that I would pinpoint for further evaluation on most farms.
I think this has been a really interesting conversation, as you said at the outset, John, to reflect on the practices and take a look under the hood. You know, in reality, milking process is where farmers spend a lot of time, and 30% of workload is involved in the milking process. Where we can reduce that, we're going to increase efficiencies and make some labour savings, and at the same time as well to reflect on where you sit on the range from an energy perspective, and are there practices again that can improve your efficiency. Thank you to John, Ryan and Fergal.
Thank you.
That's it for this week's episode of the Dairy Edge podcast, and my thanks to John Upton, Ryan Prendergast and Fergal Buckley for joining me on this week's show. Don't forget to rate, review and subscribe to the podcast. You can listen on Apple and Google Podcasts as well as Spotify, and for more information go to the Teagasc website at teagasc.ie. I'm Emma Louise Coffey, and join me next time for your Dairy Edge.